We're going to evaluate it by reversing the order of integration. So, okay, think about what the order dy dx means. It means you integrate with respect to y first and then with respect to x. And these inner limits of integration tell you that y lies between what? X on the bottom and then 2. So y lies between x and 2, and then x, these outer limits of integration tell you what? X lies between 0 and 2. So draw the region. Draw the region. I think we can safely draw just in the first quadrant here. Okay, so think about the endpoints of both intervals. Y equals x. It's just the 45-degree line, right? Or x equals y. Okay. So let me draw the 45-degree line just in the first quadrant, though. About like that, maybe? Okay. We'll say that's y equals x. And then, okay, so y equals 2. So that's one end, right? X equals y or y equals x. The other end, y equals 2. What is that? Horizontal line at a height of 2, right? So we'll say that's a height of 2, and goes something like that. By that. Okay, x equals 0 would be what? Yeah, it could be part of the y-axis. And then x equals 2, perhaps. I'm going to make it dotted because I'm not positive yet. Okay. Okay. Now, I see two regions that you might think R could be. I mean, there's a way to figure it out for sure, but you might think R is that region, that triangle right there, or that. Now, here's a way to tell for sure. dy dx is associated with what kind, that order of integration is associated with what kind of rectangles? dy dx vertical rectangles. Okay. So, if I were to draw a vertical rectangle down here, which I'm not saying is right, what would give you, what number or function would give you the bottom of the rectangle? So the inner limits of integration are given by the top and bottom and top of the rectangle, right? So it'd be 0 to x. If this were the region down here, the inner limits of integration would be 0 to x. That's not what it is. So that's not right. Yeah. Erase all that fun stuff. Wrong. What if I put it in here? Then the bottom is x. Oh, that matches perfectly. And the top is 2. That matches perfectly. So the region is this upper triangle. And then, of course, x does go from 0 to 2, which I drew the line dotted because it's really just this intersection point that gives you the x-coordinate. The x-coordinate of this intersection point has to be at 2, right? In fact, that has to be on 2, 2, since it's on the line y equals x. Right? Okay. So now what do we do to reverse the order of integration? Let's draw a horizontal rectangle. So a horizontal rectangle, something like that. Now, instead of thinking of it y equals x, what do? We think of it as x equals y. Okay, so we set up, here's your template integral. So this integral up here is going to equal, okay, the integrand doesn't change. It's still e to the y squared. But it's going to be a dx dy, so you're going to integrate with respect to x first. And then to get the inner limits of integration, you look at the left end for the lower limit of integration, the right end of the rectangle for the upper. So what's the left end given by, you think horizontally, what's the horizontal position? 0. And remember, it's x in terms of y, but it's just 0, right? Okay, so 0 to y. Yep. 0 to y. Does everybody see that? You look at the left end of the rectangle. That's x equals 0 horizontally, right? The right end is given by the function, the 45-degree line, which is x equals y. It's got to be x. When you when you integrate in this order, it's got to be x in terms of y. For the inner limits, yeah. You'd go from lowest value to highest value. So just think left end of the horizontal rectangle, or the representative rectangle, to the right end. Okay, and then what does y go from? Think low to high. 0 to 2. Now, does everybody see why it's necessary to do this? If you were to evaluate this guy as given, you'd have to find the antiderivative for e to the y squared. There's no antiderivative, no closed form antiderivative for e to the y squared. You'd have to resort to series or something like that. Whereas if you reverse the order of integration, what are you integrating with respect to first? X. And so e to the y squared is just a constant with respect to x. And then when you evaluate it, you're going to get something that's very doable. So it's probably worth evaluating. Let me show you. So we integrate just with respect to x. This guy's a constant, so we'll have just the outer integral symbolism left. And then I'll leave e to the y squared out of it. We integrate with respect to x. We get x evaluated from 0 to y, and then the dx is gone, but we have the dy, right? That'd be the way to write it down. And then what do you get when you evaluate x from 0 to y? Because I said so. Okay, is it okay if I put that result right there, though, and switch the multiplication around one more time? Okay. So if I do that, I'll get integral 0 to 2. This becomes just y, e to the y squared, dy, and then what method's going to work on that? Substitution, right? So you're going to let u equal y squared, the exponent, and then what's du? 2y dy. So you have y dy. You almost have a perfect dy. What do you need? Multiply by 2, and then multiply by a half out front, so you haven't changed the value. So I'm not actually making the substitution, am I? But if I did, disregarding the limits of integration, what would I have inside? If you're having a tough time seeing it, you could do this. You have e to the y switch. Now, I know I'm being fickle about my order of how I write this multiplication right here, but just so you can see it, you have e to the y squared and then 2y dy. Now do you see the perfect du? Your perfect du, when you write it this way, and had I been thoughtful about it, I would have written it this way to begin with. This is your perfect du because this is u. So it's e to the u du. Okay, so then you integrate e to the u. What's the integral of e to the u? E to the u. So we still have the 1/2 out front. And then we don't actually make the substitution. So when we say e to the u, we really mean e to the y squared. And then you evaluate from 0 to 2. And then apply the fundamental theorem. What do you get? E to the 4th, and then minus e to the 0 squared, which is just 1. Make sense? And then I'm not going to distribute the 1/2. I'll just leave it like that.